Hello everyone, welcome to lesson 8-3, area of composite figures. We will continue to address how do measurements help you describe a real world objects, and our vocabulary is composite figure. To begin, we're going to look at the real world problem regarding stained glass windows. These are some examples of stained glass windows. You can see over here that we have, this one has tessellations, okay, and it has a number of rows. For the middle one, we have different colors, okay, and where these stained windows may be commonly seen are at traditional churches. And here's the example provided by the book. So an image of a stained glass window is shown below, right there. Identify two of the shapes that make up the window. Two of the shapes that make up the window. Okay, and here we have triangles, we have circles or semicircles. Okay, the entire window itself is a rectangle. So two of the shapes are circles and triangles. Question 2. How could you find the area of the entire window except for the shapes you identified in exercise 1? So these are the shapes we identified, circles and triangles. How could we find the area with the exception of the circles and triangles? Well, if we have our window here and it's a rectangle, I would solve for the entire area of this rectangle. Then solve for the area of the triangles. Okay, remember the area of the triangle is half of a rectangle. Solve for the area of the circle. And once I have all of these areas, and these look to be congruent, these triangles are congruent, these circles are congruent, okay, so you would really only have to solve for one triangle and multiply by 8, and solve for one circle, multiply by 2. Once you have all of those areas, you subtract it from the entire rectangle. You can see that's what I wrote here. Solve for the area of the entire window first, so the rectangle. Then solve for the areas of the circles and the triangles, and subtract those areas from the area of the window, the large rectangle. Question 3. Draw a figure that is made up of a triangle and a rectangle on the grid below. Then find the area of your figure by counting the square units. So here's my rectangle and my triangle, and I made it look like a little house. They want us to find the area simply by counting the square units, all of these squares. And we can see that along the bottom we have 1, 2, 3, 4, 5, which is the same for the triangle. And going vertically we have 1, 2, 3. So just in this rectangle we have 15. And then here we have 16, 17, 18, 19, 20, but this is kind of like a half and this is a half. So it's really more like 19. We have to take away 1. This half takes away 1, so 19. 20, and this plus this makes 21, and then maybe 21 and a half. So about 21 and a half square units. Okay, so the main point of this lesson, what is a composite figure? A composite figure is made up of two or more shapes, and it can all look into like one shape, but within that one shape there are more than one shape. To find the area of a composite figure, decompose the figure into shapes with areas you know. Then find the sum of these areas. Now here's what we're trying. So take a look at this shape here. This would be considered a composite figure, where we have a rectangle, okay, and this looks like a barn, or even if you're looking at a basketball court, this could be the foul line to a basketball court, and this is the basketball hoop right there. So we have a rectangle, right, the foul line, and the semicircle crease. All together, this is considered a composite figure because it's made up of a rectangle and a semicircle, and you know how to find the area to these two shapes. Once you do, you add them up and you get the area for the entire composite figure. And just as a review, here are the formulas we have worked with so far. Now, this would be a good time to to pause and take a screenshot so that you have this readily available, maybe on your desktop, and you can always go back to it. So a parallelogram, the area of a parallelogram is the product of any base and its height. Any base can be any side. You choose any side, and then you measure the distance from the parallel lines, okay? And that would be the height. So its area equals base times height. A triangle is half of that, right? So the area of a triangle is half the product of any base, b, and its height. So half the base and the height. Because in a parallelogram, you have two triangles. So you really just need the half of the parallelogram. For a trapezoid, the area of a trapezoid is half the product of the height and the sum of the bases, base 1 and base 2. So you take base 1 and base 2, right? The line on the top and the line on the bottom. For example, let me show you this idea here, okay? This right here is a trapezoid, okay? This is a trapezoid. So you can consider this one base and this one the other base. So you're going to add base 1 plus base 2. The distance from here to here, let's say, could be 5 units, and here 2 units. So you add them together right there, base 1 plus base 2, so it would be 7. And then you take your height, okay? Your height could be this one right here. You could use it as a height if you'd like. And you half that height. And then you multiply half of that height times your base 1 plus base 2. Okay, we'll practice that as we go through this video. And finally, the area of a circle, as we just did in the previous lesson, area equals pi times your radius squared. And here's the example of a few composite figures. Now this, imagine that little red dotted line is not there. You have this shape that almost looks like the letter Z sort of thing, right? You see it? Like a thick Z. And then we draw a little line through there to show that we have a parallelogram and a rectangle. And then over here, this looks like the basketball key I was telling you about, where you have a rectangle and a semicircle. And in this oddly shaped, kind of looks like this could be the roof to a museum or a very unique looking building. If you were to divide it right down the half right there, okay, right down the middle, you have a triangle and a trapezoid. This could be even a right angle triangle. Okay, so let's look at the example of our first composite figure. Now remember to keep close track of everything I'm talking about. You could write it out as I am speaking about it, or simply look at this very, very carefully. To be a more active learner, you could rewrite everything that you're seeing me point out. So this is the figure, and it almost looks like an ice cream cone that's been discombobulated a little bit to the side. This is your triangular, and this is the top, okay? But this is the shape, and it's a composite shape because we see that it's made up of a semicircle and a right angle triangle. So really you're solving for two. You're solving for the area of a semicircle, so which means you solve for the area of the circle, and then you times it by half so you can get half of it, because you only want half of the circle. And then here you solve for the area of a triangle, which is base times height, and it's half of it. Base times height will give you the whole rectangle all the way to here like this, but we only want half of it. We just want this bottom half. So you times it by half as well. And you can see that your area of a triangle is 33 units, or 33 meters. And over here it's approximately 14.1. Remember, whenever we work with pi, it's always going to be approximately 14.1. When you add them together, you get 47.1 square meters. That's what this area is. Okay, let's work on this one together. If you think you understand how to solve for this without this little corner piece, you can go ahead and pause the video now and then check your answer. Okay, find the area of the figure. Round to the nearest tenth if necessary. Now here we have a shape, right? A rectangle, and we're missing a little piece right there. The little piece we're missing is a right angle triangle. And you know why triangle? Because this is right angle, and this is right angle. Specifically because these two are right angle, this one will also be right angle. So this is the little piece we're missing. It would go from here to this corner and down, right? Right there. Now, how long are these dimensions for this very small triangle that we have in the corner? Well, you can see that along the bottom, from this corner to this corner, we have 25. While up here at the top, we have only from here to here, we have 20. So what's the difference? It's 5, right? So that must mean that this piece right there is 5 inches. Okay? The same goes for the side. From here to this point we have 13. But if we wanted to go all the way to the top, it would be the same as this, which is 20. So what's the difference between 13 and 20? Okay, it's 7. So this side will be 7 inches right there. Now that we know that, let's solve for the entire rectangle. And we know that the fullest extension is 20 by 25, right? Because this one's missing the 5 here, and this one's missing the 7 here. So it's 20 by 5 to get the entire rectangle, okay? So our formula is going to be area equals length times width times width, or if it were a parallelogram, it would be base times height. Essentially, it's 2 dimensions. So you can call it length times width or base times height. It doesn't really matter what variables you use, as long as you're multiplying these two variables, okay? The 2 for this variable. And area equals 25 times 20, which equals area equals 500. 500 inches squared. Okay, and that's the entire rectangle. Don't keep in mind, okay? Now we need to solve for this little triangle and subtract it from our 500, and that'll be the area of only the blue area. For a triangle, we have area equals half the base times the height. So it would be base times height right here, right? Base times height. Let's replace those variables. And when I replace my base, I get 5, which you know it's up here, okay? And when I replace my height, I get 7, which is right there, okay? So I just replace these values into my equation. Now 5 times 7 is 35, okay? Times a half. What's half of 35? Some of you already know. Is 17 and a half. Okay, so 17 and a half inches squared is that little triangle. Now we go ahead and we take this value away from this value, because this value is the entire rectangle. But now we have to subtract this little triangle away from it. And when I subtract it, okay, as you see, I've added it down here. So 500 minus 17.5, I'm going to get 482.5 inches squared. And that right there, everybody, is the area of only the blue area. Example 2. A miniature golf hole is composed of a trapezoid and a parallelogram. How many square feet of turf does the hole cover? So you're creating a small miniature golf course, and you realize that you need that green turf to cover the entire area. And you can see that we have a trapezoid. If you were to cut it down, write down this, slice it right here, and a parallelogram, okay? So that means we're looking for the area of 2 figures. The area of a trapezoid, the area of a parallelogram. Write down your formula. So in the area of a trapezoid, you have to add the 2 bases, okay? Base 1 plus base 2. You can see there, 2 plus 3, 2 plus 3. Then you multiply by the height, which is 3 feet, okay? Or 3 feet, this could be the height. And you get 7.5, oh, times a half, of course. And then you get 7.5. And then the parallelogram. You have your height times your, or your base times your height. And there it is. 6 times 2.5 is 15. You add the 2 together, and the area is 22.5 square feet of turf. If you think you got it, go ahead and try this problem. If not, continue watching. You can pause the video now. Question B. Pedro's father is building a shed. How many square feet of wood are needed to build the back of the shed, shown on the right? So here's the back, where we have to build the little top part, the triangular part, and the back, rectangular. Altogether, it's one shape, right? But we have a triangle and a rectangle. So I will use both my formulas, the area of a triangle and area of a rectangle. Area of a triangle equals half the base times the height. Now remember, these are just dimensions. You notice here that we have the height of 4 and the base is from here to here. Well, that's the same one as here, so it's 15. So it's 4 by 15. But because I have to half one of these, I'm going to halve the even number because it's easier. So it's half my height times the base. Remember that commutative property of multiplication states that we can multiply these two first, or we can multiply the half times the height first and then the base. It does not matter the order in which we multiply them in. So I will multiply the half times the even number, which is my height, okay, so that I get an even number too. If I were to half the 15, I would get 7.5, and I just don't want to work with a decimal. So I've gone right ahead and half the height. You see that? Half the height. It's 4. I put 2 here. Times the base. Times 15. So the area is 30 square feet. And now let's do the area of our rectangle. So length, 15 times width, 12. Equals, so 15 times 12 equals 180 square feet, right? And then I just have to find the sum of the two. And when you do, we have 180 plus 30 is 210 square feet. So let's say I could just put a big plus sign right here. Oops. Big plus sign right there where I'm adding the 30 plus the 180, and I will get 210 square feet. That's how much wood you would need. For example 3, we're going to find the area of a shaded region. So use the areas you know to find the area of a shaded region. Over here, we have a rectangle, and it looks like its corners have been cut off. And the dimensions for the corner is 1 by 1, right? Times a half. So let's say, and they're little triangles, so we have to use the formula for triangle, which is area equals half base times height. Okay, so you're going to halve the base times of the base, one of these times a half. So it'll be, for example, 1 times 0.5, right? And that's 4 times. 1, 2, 3, 4. And you can see that they've done that here. They did half base times height times 4, because it's 1, 2, 3, 4. So they consolidated it. Rather than figuring it out 4 times, they simply solve for one triangle and multiply by 4. Replace the variables, okay, where you have 4 times a half is 2, and times 1 times 1 is going to remain as 2. So the area of all 4 together is 2 square inches. We also need to find the entire area of our rectangle, including the triangles. It will include it. As if they're there, they have not been cut off. So it's 5 by 12. So length times width, 12 times 5 is 60. Now that we have that area, we have to subtract the triangles that have been cut out, the corners. So it's 60 minus 2 is 58 square inches. For example 4, okay, we will find the area of the shaded region. So we have 2 rectangles. We have a large rectangle and then an area that is not shaded in white. So simply we solve for the entire, okay, rectangle. So 25 by 42. You multiply those 2 values, those 2 dimensions, and you have the entire area. But then you also solve for 22 by 20, and you have the area of the white. Then simply subtract this white from the entire blue. And you can see that's what they've done down here. You solve for the entire area, okay, this large one, 42 by 25, and you get 1050. And then the part that's not shaded is 22 by 20. So you see 22 by 20 is 440. You take the large amount and subtract the smaller amount from it. Okay, take this large one and subtract the smaller from it, and you get 600 square meters. And that's just this blue shaded area, 610 meters. Okay, so since you got it, go ahead and pause the video and try C. For C, they want a diagram for a park is shown. The shaded area represents the picnic sections. Find the area of the picnic section. So here's a park, and they designated this area right here. It looks kind of like a hatchet, and this is the handle, and this is the pointy part. Okay, as the picnic area. Well, when we cut it up, we can see that we have a triangle and we have a rectangle. The height of our triangle, right here, you can see this, is 50 because we match it to this one, and this one's 50, you see? So this is 50 yards, right? What about the bottom? What about from here to here? Well, we know that this is 120 along the top, and this is 150 from here to here, so this must be the difference between 120 and 150, which is 30. Okay, 30 yards right there from here to here. Okay, and then for the rectangle, we're given the dimensions 60 and 25. So go ahead and solve by using the area of a rectangle and the area of a triangle. If you can't remember, here are the formulas. The triangle is area equals half base times height. Okay, so half your base right here could be 15 times 50, right? Half the base is 15, half of 30 is 15, times your height, 50. And then your length times width, 25 times 60, right there, 25 times 60. And then add the two together, and your sum will be your yards squared of the picnic area. I'd like to see your answer in class. And here's the guided practice. Take a look at it. Feel free to try it if you'd like, or wait for us to do it together in class. See you then.